I need to know, to solve this problem, how many moles are in here. In here, in here. Then I'll add up all the moles and get the moles of this divided by total moles. In other words, the mole fractions. I need to know the mole fractions, because these volumes are all different and the pressures are different. With these two different variables for all of them, I can't just add up the pressures to find the total pressure. So this is how to find the moles of CO2, for example. Now PV is right here. There's P and there's V. So here, let me call CO2 gas 1, and this is gas 2, this is gas 3. They're all at the same temperature. Excuse me. Now, what about the total moles, so I can get a mole fraction? Well, the pressure total times the volume total equals the total moles times RT. Let's see, solve for N here, so I can get a mole fraction. And T equals P total V total over RT. Alright, so I have these two. Let me just combine them. So N1 for carbon dioxide over total moles is equal to, just substitute in here, start with that, P1 V1 over RT over, and now NT, so that stuff over there, P total V total over RT. Alright, so the RT's cancel, and I've got the mole fraction N1 over NT, N total equals P1 V1 over P total V total. Okay? So the mole fraction of this first gas is P1 V1 over P total V total. Similarly, the mole fraction of the second gas is going to be equal to P2 V2 over P total V total. Similarly, here, excuse me. Now, and now I can get the total pressure, because the only variable that is unknown in each of these is the PT. You see, volume total is just the sum of all these volumes. P1 is just right there. V1 is just right there. All these pressures and volumes are given. I just cannot get P total by adding these P's up, because the volumes are all different. Volumes are just additive. They are an extensive property. However, the pressure is not additive. Not necessarily anyways. Because I could have a room full of gas at 2 atmospheres. If I took a small amount of that gas, kept it at the same pressure. I mean, this part right here, this is also 2 atmospheres. You know what I'm saying? So pressure is not necessarily an extensive property. So I cannot just add it up if other things are not equal. For example, the volumes. If the volumes are not equal, I cannot simply add up these pressures. So I have one unknown here, and what do I know about these mole fractions? How can I put these mole fractions all into an equation like this? Remember that the mole fractions all add up to 1, don't they? Meaning, these things also add up to 1. So that means P1 V1 plus excuse me, P2 V2 plus P3 V3 over P total V total equals 1. What does that mean? Well, that just means I can multiply both sides by P total V total. Alright, so I will get P1 V1 plus P2 V2 plus P3 V3 equals P total V total. I can divide both sides by V total, and I will get P total. So in other words, P total is equal to, I will now substitute things in, 2.13 times 1.5, 2.13 times 1.5 plus 0.861 times 1, 0.861 plus 1.15 times 2, so that's just 2.30, and all that's divided by the total volume, which is, this is 1.5, this is 2.5, this is 4.5, 4.5 liters. And I get 2.13 times 1.5 plus 0.861 plus 2.3 equals, divided by 4.5, that's 1.41. 1.41. Oh yes, significant figures, right? That's 1.41 atmospheres. That is my final answer.